Okay, on page 2 of your pamphlet or your booklet, you have the next problem. What is the cost of a taxi ride? In the last problem, we looked at the table to give us information on solving the problem. And on this time, we have to look, and the table is empty, and we're asked to write an equation. And there's not much information on the in the situation, so we have to look at the graph to see if it provides us with data. And I see that there are some points. So the question is, what is the cost of a taxi ride? So let's take a look at the graph. The independent variable is miles, so let's go ahead and label those. Go ahead and label that on your paper. And the cost of the ride is dependent on how many miles he travels, so that's our dependent variable. So now let's look at the graph to help us fill in our table. If we travel 1 mile, then it's going to cost us $12. Okay. And if we go 2 miles, it's going to cost us $14. Okay, so that's 14. And if we go 3 miles, it's going to cost us $16. And if we go 4 miles, it's going to cost us $18. Well, that's not on there, so let's talk about if we go 5 miles, it's going to cost us $20. But how much is it going to cost us for $10? To figure that out, we have to look and say, if I put in 1, I get 12. So would I add something to 1 to get to 12? To give us a better idea of the change in x, we can look at the graph and follow the pattern. So if this was 14 and 12, could it cost me at $10? It might cost me $10 just to get a cab. So I'm going to put a dot here. When x is 0, when I'm not traveling anywhere, just to get a cab, it's going to cost $10 for the cab to come and get me. So if that's the case, then my constant is $10. So it's going to be plus 10 somewhere here. So if I think about it, now I'm left with, okay, so it's going to cost me $10 already, but if I travel 1 mile, it's going to cost me $2, because 1 times 2 is 2, and 2 plus 10 is 12. So really, I can think of my expression as 1 times 2 plus 10, because it's going to cost me $10, a constant that doesn't change whether I go 1 mile or 2 miles. So let's see if our expression holds. If I go 2 miles, is it still $2? Plus 10, well, 2 times 2 is 4, plus 10 is 14. Okay, so let's check the next one. 3 times $2 plus 10 is 16. Okay, so that means that leaves us to this. And then when we get to 10, it must be 10 times 2 plus 10. So 10 times 2 is 20 plus 10 is 30. So that's going to be 30. And if I go 15 miles, then it's going to be 15 times 2, which is 30, plus 10 is going to be $40. So now we have a table of values. And so how do we write that equation? Well, we look at our expression. It's going to be 2 times whatever x is, or 2 times m, plus 10. So how do we write that? We have to set it equal to y. So we're going to write y is equal to, and what's our expression? It's going to be m, that's the number of miles, times 2. But that's the coefficient 2m, because that's the standard way to write it, is to write the coefficient. So it's 2m plus the constant of $10 that it costs us just to have the cab pick us up. And that is a solution to this problem. So page 3 and 4 is classwork, or our classwork for today, and I will write the solution here or show you the solution, but you can go ahead and pause the video if you feel like you can go ahead and do page 3 and 4 independently and then come back and check your answer. That's fine. So let's start with this problem. This is house plumbing charges. Notice that the situation has blanks in it. So we're going to be looking for trying to find our data somewhere. If we look at the table, that's not completed, so we can't use that. When we look at the graph is not completed, so there's no data that can help us fill in anything else. But we do have an equation. So in the last 2 problems, we found we use the data first from the table, then on page 2 we use the graph to help us. And this time we're going to use the equation to help us fill in the rest of the information. So let's take a look. This is house plumbing charges. House plumbing charges something per half an hour for labor in addition to a service fee of something. Write an equation that could be used to determine C, the total cost for plumbing repairs by house plumbing for H hours. So let's go back here. Let's go to the equation. So we can tell that from the equation that this 25 is a constant. So it's going to be $25 no matter what, kind of like our taxi ride. This is 15 is a coefficient of the hours that they work. So this looks like it's going to be $15 per hour. So let's use that and let's put that in our table. So for 1 hour of work, it's going to cost us $15, but it's $15 times an hour plus the 25 that you're going to have to pay. So let's think about that. This is 15 times 1 is 15 plus 25. So let's see if we can write that better. This is $15 times 1 hour. It's going plus 25. So 15 times 1 is 15. Plus 25 is going to be, looks like $40. Okay, so far we can do that. So using this information, maybe we can fill out this problem right here. So house plumbing charges something for half an hour. Well, if he charges $15 for 1 hour, then it must be half of that, must be $7.50. So in addition to the service fee, and we said the constant was 25, so we have to pay $25 just to call a plumber, and that's true in real life. If you call an electrician or you call a plumber just to make a house call, they'll charge you a fee before they do anything. So now we have the situation, and let's define each variable. The C is the cost, and the cost is dependent on how many hours he works. So we have the C represents the cost, and the H represents the hours. And so then we can, with that information, we can write down, we can fill in our table. So now we know that this is going to be 1.5. When he works 1.5 hours, then it's going to be 1.5 times the $15 plus the 25, which is going to be $47.50, because it looks like he worked a half hour more. And then we said for 2 hours it would be $15 times the 2 hours plus 25, which would be $55. And let's fill out the first one, which was half an hour. If he works half an hour, it's still $15, but it's only half an hour plus the 25. So it's going to be less $40, so $32.50, about $32.50. So now we can scroll down a little bit and look at our table. Let's finish this table here with 15 at 250 would be $62.50. So now that we have our x and y, this is our independent variable, and this is x and this is y. Let's just put that on there. You should label this x and y just for habit. This is x, our independent variable. Put it up so you can see it. And y. And do you remember what we said was the process? That is our expression. Okay. So now now that we have our x and y values, there's our ordered pairs, 0.5 and 3250. So let's plot that. When we have when we work a half an hour, it costs us, so we're going to go over to a half, it's going to cost us $32.50, so somewhere around here. And then we said if he didn't do anything, it would still cost us $25. And then if he works for 1.5 hours, which is be 1.5, it would cost us $47.50. Oh, sorry, we missed the 1. When he works 1 hour, it costs us $40. And then if he works 1.5, that would be $47.50. So somewhere around here. And if he works for 2 hours, then it's going to cost us 2 hours. It's going to cost us $55. That's 2. So go over 2, and then go up to 55. So that's pretty much what our graph looks like. So now we have our situation, and we have our variable, we have our equation, we fill out our table, and now we have a graph. So can you tell what kind of relationship this is based on our graph? Yes, if you think that it is an additive relationship, then you are correct. And why is it additive? It's because our graph does not go through the origin, 0, 0. So good luck, work on page 4 on your own, and then you are going to do pages 5 through 7 for homework, and we'll review it on the next day.